We'll start off with the angle addition laws. Cosine of a sum is cosine cosine minus sine sine. Sine of a sum is sine cosine plus cosine sine. And tangent of a sum is tangent plus tangent, all divided by 1 minus tan. All right, now for a double angle, let beta be the same as alpha. Then alpha plus beta is 2 alpha. And plugging it in here, you get cosine of 2 alpha is cosine cosine, cos squared alpha, minus sine times sine, sine squared. This should be an alpha. Oh dear, I need to change that. Let me make a note here. 361 sine squared alpha. All right, now throwing in this beta equal to alpha here, you get sine 2 alpha here. So be sine alpha cos alpha plus cos alpha sine alpha, so twice sine alpha cos alpha. Setting beta equal to alpha here, you get tangent 2 alpha over. Here would be 2 tan alpha in the numerator over 1 minus tan squared alpha. Now this rule here, we can change a little bit because of the Pythagorean relation. Cos squared plus sine squared equals 1. Therefore, this cos squared we can write as 1 minus sine squared. And so you get this becomes 1 minus 2 sine squared alpha. And negative sine squared is cos squared minus 1. So we rewrite that as a cos squared minus 1 and get 2 cos squared alpha minus 1. So this is the double angle formula for cosine. Here it is for sine, here it is for tangent. Now, I'm going to start off with these two versions of the double angle formula for cosine. And let's derive a half angle formula. The idea is that starting from each of these, we'll solve for cosine alpha in terms of cosine 2 alpha. So from here, after a bit of algebra, cos squared alpha is cosine 2 alpha plus 1 divided by 2. And sine squared alpha, after a bit of work, is minus cosine 2 alpha plus 1 divided by 2. Now I'm going to call this 2 alpha, call it theta. So the alpha is half of theta. So cos squared theta over 2 is cos theta plus 1 over 2. Sine squared theta over 2 is minus cos theta plus 1 over 2. Then after you take some square roots, cosine of a half angle is plus or minus root of 1 plus cos theta over 2. Sine of half an angle is plus or minus root of 1 minus cos theta over 2. Plus or minus depends on the quadrant that theta over 2 is in. Tangent is the sine, tangent of a half angle, the sine of half angle over cosine half angle. And if you divide these out, it turns out to this. But we can do a little bit better. After, if you look at page 244, they have a derivation of tangent of a half angle is 1 minus cos theta over sine theta. And that's the same as sine theta over 1 plus cos theta. So this is the tangent half angle formula, as is this, but it's not quite as useful. And here are the half angle formulas for cosine and sine. Let's review that. So double angle formulas here. I'll change this beta to an alpha in the canvas. My apologies. And half angle formula for cosine and sine here, and for tangent here. So suppose sine theta is 3/5 and it's in quadrant 1. So here we are, like this. Fine. Sine of twice the angle, cosine of twice the angle, sine of half the angle, cosine of half the angle. Sine of, okay, if this is the triangle, then sine is 3/5 and cosine is 4/5. That's, we need to know both of these to use the double angle formula. Sine of 2 theta is 2 sine theta cos theta, so it'll be 2 times 3/5 times 4/5. And okay, this equals, after some multiplication, 24 25ths. Cosine of 2 theta, we can write it in terms of sine. 1 minus twice sine squared. Although I could also do 2 cos squared minus 1, but I always think it better to use the freshest ingredients, so to speak, to use the original data rather than anything derived from it, because there's less chance of making a mistake. So anyhow, cosine 2 theta is 1 minus twice sine squared. So that's 1 minus twice the square of 3/5. After a bit of algebra, a bit of arithmetic, you get 7/25. So here are the double angles. Now, theta is in quadrant 1, therefore so is theta over 2. So therefore the sine and the cosine of theta over 2 will be positive. Sine of theta over 2 is root of 1 minus cos theta over 2. That's 1 minus 4/5 all over 2. And after a bit of wrangling, that's root 10 divided by 10. Cosine of theta over 2 is again plus, it's quadrant 1. 1 plus cosine over 2. It'll be 1 plus 4/5 over 2, and after a bit of wrangling, 3 root 10 over 10. Now, cosine of 165 degrees. What's that? All right, now 165 degrees is in the second quadrant, and that's where cosine is negative. And furthermore, 165 degrees is half of 330 degrees, which is 30 degrees short of a full rotation. Okay, cosine of a half 330 will be a negative. That's the second quadrant. 1 plus cosine 330 over 2. All right, for 330 degrees, that's 30 degrees short of a full rotation. So we have a 30, 30, 60, 90 triangle here, a 1 here, a root 3 here, a 2 here. Cosine is root 3 over 2. So this becomes minus 1, 1 plus root 3 over 2 all over 2, which you can work out as 2 plus root 3 over 2, that divided by 2. And after a bit of wrangling, that's minus root of 2 plus root 3 over 2. This is odd because it has a square root inside a square root. Here we have some proofs of identities. And again, I require in these problems that you go through the full detail. Here we go, the full proof. Prove that sine of 3 theta over sine theta minus cosine of 3 theta over cos theta equals 2. I will start with the left side, sine 3 theta over sine theta minus cos 3 theta over cos theta. And after some multiplying, sine 3 theta cos theta minus sine theta cos 3 theta over sine theta cos theta. But look at this, sine cosine minus cosine sine. Well, that's a angle subtraction formula for 3 theta minus theta, sine of 3 theta minus theta. Also multiply above and below by 2. So in the numerator, you get 2 sine 2 theta. You have 2 sine theta cos theta. That's the double angle formula for theta, sine of 2 theta. So you get 2 sine 2 theta over sine 2 theta. These signs cancel. We're left with 2, which is the right side. And we're done. Okay.